When facing arc fault circuit interrupter or AFCI compatibility issues with shared neutral circuits, several solutions can be considered. Firstly, some AFCI breakers are specifically designed to function with shared neutrals. These specialized breakers incorporate a feature that continuously monitors the neutral current. They are engineered to detect any imbalances that might indicate the presence of an arc fault. It is crucial to exercise caution, as not all AFCI breakers are suitable for shared neutral applications. Before proceeding with this option, meticulously review the manufacturer's specifications to confirm compatibility. Secondly, another approach involves utilizing an AFCI tandem breaker. This type of breaker is designed to protect two circuits while occupying a single breaker space in the electrical panel. The installation process includes running a new 14/2 wire from the tandem breaker to a junction box located within the bedroom. At the junction box, the new 14/2 wire should be connected to the existing 14/3 wire. The purpose of the new 14/2 wire is to establish a dedicated neutral connection for the AFCI circuit, thereby ensuring proper operation. Thirdly, consider installing a combination surge protector and AFCI wall outlet. These devices offer dual protection against both power surges and arc faults. A significant advantage of this solution is that it typically does not necessitate any modifications to the existing wiring. As a result, these devices can be installed in existing bedrooms without the need for extensive wall demolition or rewiring. Fourthly, smart home devices can provide AFCI protection. Certain smart home devices, exemplified by the Leviton Load Center, offer AFCI protection capabilities without requiring alterations to the existing wiring infrastructure. These devices employ sensors to continuously monitor electrical activity within the circuit, enabling the detection of arc faults. Regardless of the chosen solution, it is essential to emphasize the importance of consulting with a licensed electrician before undertaking any modifications to electrical circuits. Electrical work can be hazardous if not performed correctly, and a qualified electrician can ensure that all work is completed safely and in compliance with applicable electrical codes. AFCI serve as critical safety devices in electrical systems, playing a vital role in preventing electrical fires. By detecting arc faults, which are a common cause of electrical fires, AFCIs can quickly interrupt the circuit and mitigate the risk of a fire. In situations where feasible, it is highly recommended to address the underlying wiring issue by physically separating the circuits and providing a dedicated neutral conductor for each individual AFCI circuit. This approach represents the most robust and reliable method for ensuring proper AFCI functionality and enhancing electrical safety. When selecting AFCI breakers, it's crucial to understand the different types available. Combination type AFCIs offer the most comprehensive protection, detecting both arc faults and ground faults. Branch feeder AFCIs protect the entire branch circuit, while outlet branch circuit AFCIs protect only the portion of the circuit downstream from the outlet. The National Electrical Code, or NEC, provides detailed guidelines on where AFCI protection is required. Generally, AFCI protection is mandatory in all branch circuits that supply outlets in dwelling units, including bedrooms, living rooms, and dining rooms. There are some exceptions, such as for circuits that supply only appliances. When dealing with shared neutral circuits, it's important to verify the circuit's integrity before installing any AFCI devices. Ensure that the neutral conductor is properly sized to handle the combined load of the circuit sharing it. An undersized neutral conductor can lead to overheating and potentially cause a fire. To test the neutral conductor's capacity, measure the current flowing through it under normal operating conditions. The current should not exceed the ampacity of the neutral conductor, as specified in NEC Table 310.15b16. If the neutral conductor is found to be undersized, it must be replaced with a larger conductor to ensure safe operation. In addition to verifying the neutral conductor's size, it's also important to inspect the wiring for any signs of damage or deterioration. Look for cracked or brittle insulation, loose connections, and corrosion. Any damaged wiring should be repaired or replaced to prevent electrical hazards. When installing AFCI breakers, follow the manufacturer's instructions carefully. Ensure that the breaker is properly seated in the panel and that all connections are secure. After installation, test the AFCI breaker to verify that it is functioning correctly. Most AFCI breakers have a test button that simulates an arc fault. Press the test button to trip the breaker. If the breaker does not trip, it may be defective and should be replaced. In cases where it is not feasible to run a new dedicated neutral conductor, consider using a two-pole AFCI breaker. A two-pole AFCI breaker protects two separate circuits that share a common neutral conductor. This type of breaker is designed to detect arc faults on either circuit and trip the breaker, interrupting both circuits. When using a two-pole AFCI breaker, ensure that the two circuits are properly balanced to prevent nuisance tripping. An unbalanced circuit can cause excessive current flow in the neutral conductor, which can trigger the AFCI breaker. To balance the circuits, distribute the loads evenly between the two circuits. Measure the current on each circuit to ensure that they are approximately equal. If the circuits are significantly unbalanced, adjust the loads to achieve a better balance. Another option for dealing with shared neutral circuits is to use an AFCI protected receptacle. An AFCI protected receptacle is a special type of electrical outlet that incorporates AFCI protection. This type of receptacle can be installed in place of a standard outlet to provide AFCI protection for the circuit. When using an AFCI protected receptacle, ensure that it is properly grounded. A properly grounded receptacle provides a safe path for fault current to flow, which helps to protect against electrical shock. To test the grounding of the receptacle, use a circuit tester. The circuit tester should indicate that the receptacle is properly grounded. If the receptacle is not properly grounded, consult with a licensed electrician to correct the grounding issue. In some cases, it may be necessary to install a new grounding electrode system to ensure proper grounding. The NEC specifies the requirements for grounding electrode systems in Article 250. It is important to note that AFCI protection is not a substitute for proper wiring practices. Always follow the NEC guidelines when installing electrical wiring. Proper wiring practices include using the correct wire size, making secure connections, and protecting wiring from physical damage. When working with electrical wiring, always disconnect the power at the circuit breaker before starting any work. This will help to prevent electrical shock. Use insulated tools when working with electrical wiring. Insulated tools provide an extra layer of protection against electrical shock. Wear safety glasses when working with electrical wiring. Safety glasses will protect your eyes from flying debris. If you are not comfortable working with electrical wiring, consult with a licensed electrician. A licensed electrician has the knowledge and experience to safely and properly install electrical wiring. In addition to AFCI protection, it is also important to protect against ground faults. A ground fault is an unintentional electrical path between a hot conductor and ground. Ground faults can cause electrical shock and fires. Ground fault circuit interrupters, or GFCIs, are designed to protect against ground faults. GFCIs work by monitoring the current flowing through the hot and neutral conductors. If there is a difference in current, it indicates that a ground fault is present. When a ground fault is detected, the GFCI quickly trips the circuit, interrupting the flow of electricity. GFCIs are required in certain locations, such as bathrooms, kitchens, and outdoor areas. The NEC specifies the requirements for GFCI protection in Article 210.8. When installing GFCIs, follow the manufacturer's instructions carefully. Ensure that the GFCI is properly grounded and that all connections are secure. After installation, test the GFCI to verify that it is functioning correctly. Most GFCIs have a test button that simulates a ground fault. Press the test button to trip the GFCI. If the GFCI does not trip, it may be defective and should be replaced. Surge protection is another important aspect of electrical safety. Power surges are sudden increases in voltage that can damage electronic equipment. Surge protectors are designed to protect against power surges. Surge protectors work by diverting excess voltage to ground. There are two main types of surge protectors: whole house surge protectors and point of view surge protectors. Whole house surge protectors are installed at the electrical panel and protect the entire house from power surges. Point-of-use surge protectors are plugged into individual outlets and protect the equipment plugged into that outlet. When selecting surge protectors, choose surge protectors with a high surge current rating. The surge current rating indicates the amount of current that the surge protector can safely divert to ground. Also, look for surge protectors that meet UL 1449 standards. UL 1449 is a safety standard for surge protectors. It's also worth knowing that aluminum wiring was used in some homes built in the 1960s and 1970s. Aluminum wiring can be a fire hazard if it is not properly installed and maintained. If you have aluminum wiring in your home, have it inspected by a qualified electrician. The electrician can check for loose connections, corrosion, and other problems. If problems are found, the electrician can recommend solutions such as replacing the aluminum wiring with copper wiring or installing special connectors that are designed for use with aluminum wiring. Furthermore, electrical panels should be inspected regularly to ensure that they are in good condition. Look for signs of corrosion, loose connections, and damaged breakers. If you find any problems, have them repaired by a qualified electrician. Also, make sure that the electrical panel is properly labeled. The label should clearly indicate the purpose of each circuit breaker. This will make it easier to turn off the correct breaker in an emergency. Using extension cords safely is another important aspect of electrical safety. Extension cords should only be used temporarily. Do not use extension cords as a substitute for permanent wiring. Also, do not overload extension cords. Overloading extension cords can cause them to overheat and start a fire. When using extension cords, make sure that they are properly sized for the load. The extension cord should have a current rating that is equal to or greater than the current rating of the appliance or equipment that is plugged into it. Inspect extension cords regularly for damage. Replace any extension cords that are cracked, frayed, or otherwise damaged. Finally, remember that water and electricity do not mix. Never use electrical appliances or equipment near water. If an electrical appliance falls into water, do not touch it. Turn off the power at the circuit breaker and then carefully remove the appliance from the water. Remember to consult with a qualified electrician for any electrical work.